Welcome to this concise guide on Einops. On the left, a traditional numpy snippet, x dot reshape with batch size, -1, height times width, then a transpose. What does it do? Hard to say at a glance and easy to get wrong. On the right, the Einops version, rearrange x. The batch dimension is kept as the first axis. The height and width dimensions are flattened into a single new dimension. The parentheses signify this combination. The size of this new dimension becomes 224 times 224. The channel's dimension is moved to the end. Crystal clear. The code reads like English and documents your intent. Here's the common pain. You've got a tensor of shape 32, 224, 224, 3. Is it batch first? Channels first? What do these axes represent? Different conventions across frameworks and fragile debugging when a single axis is off. We need a better, human-friendly way to express tensor intent. Enter Einops, tensor operations for humans. 4 principles. 1. Readable, patterns that spell out what each axis means. 2. Reliable, runtime shape checks catch mistakes early. 3. Efficient, minimal overhead for most backends. 4. Universal, works with numpy, pytorch, tensorflow, and JAX. Get started with pip install Einops. Then import rearrange, reduce, and repeat. That's 90% of what you'll use. Rearrange follows a simple pattern, input arrow output. Images with shape 32, 3, 224, 224. We want to flatten spatial dimensions and move channels to the end. The parentheses tell Einops to multiply height by width. The output becomes 32, 50,176, 3. Reduce aggregates over axes with an explicit pattern and a reduction. For global average pooling, we use reduce and specify which dimensions we want to calculate the mean from. That collapses height and width by averaging. Repeat expands values along new axes. Great for broadcasting. This example takes a bias vector with 256 elements and broadcasts it to a batch and spatial grid. Let's apply Einops to a real case. Vision transformers. Start with an image of shape 1, 3, 224, 224. Extract 16 by 16 patches. Rearrange IMG by providing the transformation. The result is 1, 196, 768, a sequence of 196 patches, each with 768 features. Einops shines across frameworks. In PyTorch, use rearrange directly on tensors or the rearrange layer inside modules. In TensorFlow Keras, use the matching rearrange layer in sequential models. The patterns are the same, so porting code is straightforward. Einops makes tensor code readable, safe, universal, and powerful, perfect for modern deep learning. Check out more at einops.rocks. And please subscribe if you found this useful.